Okay, good afternoon everybody and welcome back after what I hope was a very nice lunch break for you. We're now going to start two sessions on some of the issues that influence the adoption of Earth observation in the different sections. In a little while we're going to have a session on capacity building, but first we're going to talk a bit about the underlying infrastructure. Before we start, I would just like to say that we do encourage questions. There is the Slido that you can ask questions through, and I really would encourage you to take the chance to ask questions to our participants. So, let me introduce our participants. So first of all, here in the audience with me, we have Stanisław Dałek, who is the CTO of CloudFerro, and who leads the CryoDS and Wikio and several other related initiatives. Then online, we have Grega Milcinski, who I think is very well known as the general manager of Sinergise, known for tools such as Sentinel Hub and EO Browser. And then finally, we have Gedas Vaitkus, director of Geomatrix, who's an expert in geoinformation and in the automation of Earth observation workflows. So I'd like to start actually, Gedas, with you, please. Just to start, I'd really like to set the scene by asking people to give their feedback on what they think the current status of the infrastructure is that we use for Earth observation. What works well, what doesn't work well, what should be improved. So Gedas, I think you work quite a lot building workflows on Earth observation data. How does the current setup work for you as an end user?
Yes, thank you for this question, although I think this should be addressed more to those who use big cloud systems like DSs or I know CloudFerro might comment on that. But my personal opinion is that it all depends on the efficiency, and it all depends on the cost efficiency, on the income, on the spending of the company. Like, we don't have massive projects funding our activities in terms of production, so we have to be extremely innovative in the direction of this efficiency. So, well, we use our own infrastructure. We have it for 10 years already, and we are building up gradually, replacing some elements, improving. Luckily, the technological advance of the recent years gave a massive boost of performance on the hardware level, but even more importantly, new algorithms, new machine learning algorithms, database and networking elements of the infrastructure have improved dramatically. So honestly speaking, for a medium-sized country, if we're running machine learning exercise on the database to, for instance, detect crops, it runs nicely on one node with high performance, of course, but the cost of it is low. Generally, it is quite low. And electricity costs and all the other stuff, as we're using open source systems, becomes very, very competitive, I must say. So as long as we do not run global exercises, we are perfectly fine on European scale, on national scales. We're running now 7 countries, 8 countries, Ukraine added this year, 7, 8 countries, well, 1/3 of Europe. So, and it goes nicely on our own system, using Sentinel-1 as the major source of information, not Sentinel-2. So very many images, tens of thousands every year. And still, if we focus on efficiency, but not brute forcing of the result out of massive clouds, of massive data sets, if we go wisely, if we go efficiently, then taking advantage of the newest technologies, we can deliver very high quality results with pretty low performance and pretty low footprint on emissions, on everything, and of course on the cost. the production. So that is my opinion. Yes, very good to have clouds, very nice, but the data there is still not perfectly ready for production, at least in the radar part. So we have to do a lot of work on our side, and it becomes a system which is autonomous, which is the more efficient solution in our case.
Okay. I'd like to come back to that issue around the data a bit later, but in the meantime, I'd also like to ask Stanisław, because you've been involved in 2 DSs, in fact, both the Queer DS and the Wekio, as well as other initiatives. What's your feeling on the current infrastructure? What's the feedback you get from your users?
What is important and what is crucial here is the data, easy access to cloud processing ready data in formats that are easy to access with the homogeneity of data. Data homogeneity is very important. When you want to run a processing campaign over a large surface area or over a longer time frame, it's really important to have data that was processed, for instance, using the same baseline, using the same DEM, the data, the ground model, yes, using the same processing chain and parameterization. It is important to be able to access all that data using homogeneous queries to extract the data parts that you need. And not to have to wait for that data to come, to be acquired from somewhere, to be downloaded, to be the way an EO data research and then commercialization project works is that they customers usually try their algorithm on a small scale. And they may want to try it in Norway and in Japan and somewhere else where it's important. It's important for them to have the data at the fingertips so that they can easily access it and do this processing very fast and efficiently. And then to be able to scale it to a bit larger scale, then maybe to a global scale, and to be able to do it in a very smooth and efficient way, in order to scale this infrastructure and pay only for the usage of the infrastructure for 1 month of usage or for a few months of usage if they need it to run some big processing. With the modern tools like Kubernetes and the auto-scaling capabilities, this capacity may even scale automatically according to the demand of the application. This is crucial. What is also important is the tooling. Users don't want to assemble their processing chains from 7 different parts to work with different authorization schemes. They want to have a single sign-on. They want to have common identity. The service must be coherent and simple to use to be usable.
And on that note, maybe we'll come back to some of these issues in a little while, but I think I'd like to bring Grega into the conversation here, because I think I know Sinergise is a company that puts a lot of effort into making it simpler for people to use Earth observation data. What's your feeling about the general setup of infrastructure? What are the feedback you get from users here?
I mean, the best feedback that we get is no feedback, right? Because users are typically keen to complain, not that much praise. So we get feedback when things actually don't work. And I mean, here I want to confirm what Staszek said, is that having or not having the data available, that's typically the most common problem that we face. And having the data available typically means having the data immediately available, right? So, I mean, as soon as people have to wait, I don't know, minutes, that's typically already too late for most of the users. Yeah, you can have some batch processing campaigns where the minutes are fine, but again, typically when you would do it at a batch scale, then having to wait the minutes for a specific data and multiplying this by number of data sets that you'd like typically will not work as well. So again, mostly what we see from people is that they they build application based on the tools that we provide. And I mean, this is the kind of the main feedback that we get, is that we see when the applications are actually available, applications that were designed by someone else whom we have not helped, who was able to just use the services and they just worked. And I think this is like the most essential part, is that things really just work, and they work almost all the time. I mean, we are not in life critical situation where you need like 100% availability, but it really needs to work a lot. Now, I mean, often we get questions by users like kind of what benefits do all these tools that we provide bring to them, because you have all these open source tools available that do the job more or less the same as the Sentinel Hub does. But then, I mean, what they often don't realize is how much effort is needed to actually have things running. And then when you have things running, to operate and to maintain. And with all the changes that are happening, like recently, in January, we had this change of the baseline for Sentinel-2, where they simply introduced the offset for the data. And this has broken many applications that were based on either raw data or even, I mean, in Google Earth Engine, you've seen the complaints of people not understanding why suddenly NDVI is larger or lower or whatever, right? So all these small tweaks, I mean, what we did is that we simply abstracted this and made it possible for users to just get data in the past value. These kind of things are where the changes are done and where people actually benefit from the data. Now, I mean, what is clear is that the community is going more and more from like these visual-based applications, like, I don't know, precision farming, where you simply show the NDVI, into the data science based exploitation, where you need a lot of the data, and typically you need deep time series. So again, when we are talking about having data available, what is essential is that you have data available at least for a year, preferably several years, because typically you are interested in the changes that are happening over the longer period of time. So, these kind of things are really essential. And I mean, as an example, what we recently introduced is like statistical batch processing, which allows people to just enter hundreds of thousands of polygons and get time series. These are the things that are really welcome. And to be able to run these kind of services, you obviously need to have a cloud infrastructure. I mean, yeah, we could base all of this on our own infrastructure, but we need to store petabytes of data, which is expensive, if not else. So we have to rely on the cloud infrastructure, which has to have the data available and has to work. As simple as that.
Okay, thank you. Stanisław, I'd like to follow up a bit about the data, because the DSs tend to be thought of, not necessarily correctly, as processing platforms, but also as access to Copernicus data. But actually, we heard a lot this morning in the session on research about access to in situ data in particular. And then, of course, there's also some things that just cannot be done with Sentinel data, but which you need access to commercial high resolution, very high resolution data. So maybe you could just comment on how we bring together all these different sources into one place.
Well, for many use cases, data beyond Sentinel is needed. This is quite obvious for us, having operated the platform for several years. And that's why we've been expanding the data set with commercial high-resolution data from commercial providers that may be accessed using the same access methods, catalog, and processing tools that customers use for Sentinel data. There is it is an added value to have different data sets in available in one infrastructure, available immediately without the need to pre-order the data and wait for its availability, because this immediate availability of all the data you need simplifies your processing chain. The processing chain tends to be much simpler, where when all the data is there, you don't need to pre-order, because if you pre-order, you fall into all sorts of delays, and your processing speed suffers, and your processing chain gets more complicated. What you can do also when you have large data sets, many data sets in one place, of course, you can bring the first promise for the diocese was to bring processing to the data, and it still makes sense, because even with increasing internet bandwidth and internet speeds that you get inside the data center are still at least an order of magnitude larger than you can get from the internet. We are talking tens of gigs or hundreds of gigs within the data center. So this boosts efficiency. I think another thing that will be happening with as something new in this processing chain is that there will be more and more situations where people order some very specific data sets that may not be available on the platform, and this would include for me in the near future some standardized interfacing for tasking satellites. Yes, so that you can, with the amount of new satellites and new satellite fleets that you can task, I think the next big thing on your data processing platforms will be the ability to task the satellite using a standardized interface. Yes, this will, I think, bring a new level of innovation to the industry.
Thank you. Gedas, I'd like to come back to a point that you raised before around the amount of pre-processing that you have to do on the data. And I know analysis-ready data has been something of a buzzword for a while now. Is this something you would like to see done more of by the platforms that manage the data? Or do you prefer to keep this sort of pre-processing under your own control so that you know exactly what is being done?
It's a difficult question, because there is no such thing as uniform and absolutely standard analysis-ready data. For instance, in our case, we work with Sentinel-1 because we focus on Northern Europe, and we have very, very little coverage in good time of optics. Yes, we have some, but it's not enough for any reliable service and accuracy. So we focus on radar. Radar Sentinel-1 is far from being analysis ready when we take it from the service, from the internet repositories. The way we pre-process Sentinel-1 is not a classical and standard way of 64-bit stuff. We never do that, because it becomes 5 or 6 times bigger than the product we make for ourselves. We have spent a lot of time on optimizing the data structure, not the file formats or something, but the data structure itself, to make it very fast, robust, small, and so on. So the way we pre-process Sentinel-1 is different from what others would do, I'm sure, and they would even criticize us for crashing the data or changing the data too much. That's one thing. Another thing is that if we look at the processes, or if we focus on the use case, if we focus on what the client really wants, or what solution is to be delivered, immediately we see that it's not enough to work on image per image basis. It's necessary to build some kind of a temporal data flow structure, split into certain moments or fixed periods of time we sample, or we produce the statistical deliverables, and that is our real input. That is our analysis ready data. It's not just the image. It's something beyond that. It's far beyond that. And even more, to be honest, we do not work on images already for a few years. We work on a database, on a PostgreSQL database, which contains is intelligence information collected into the objects from the satellite data. So it's not playing raster analysis or imaging with a picture or with the image. So people don't want to see. They don't want to look at the images. Farmers do not even want to have any knowledge about it. They say, now it is 16th of June, and if you tell me where to go today, I will pay you just for that. I don't want to spend a second on the images, a second on any connecting NDVIs, looking at my fields. I have 50,000 hectares, which takes so and so many fields. It's split across 4 districts. And where do I go today? That's the question. That's the problem we have to deal. Behind that problem, a lot of pre-processing, a lot of image, temporal data analysis, machine learning, sampling, everything there, just to take out of the whole amount of fields those which are problematic. So we focus on that kind of service, on that kind of solution, not on something which is standard in a way where you could scale it, or you could show it. We cannot even show that, you know. It's very, very back-end stuff and very much IP-based elements we offer. Because, you know, if we give me one more minute, when I look at what Sinergise does, it's beautiful. It's absolutely incredible what they do. But the first rule of a game in business is that you should never copy what somebody else has already done. So if Geomatrix tries to find the way in the business community, it should not copy anyone else. We should not do the same thing as others already do, and do that very well. So don't ask me why we do this thing or that thing. We go just different way, because we have to survive in the business environment. We are not living on the project only. We're just trying to sell stuff there, you know. So we have to be pretty smart and flexible, and acknowledge that some guys have done excellent work and they are the best there. So why should we do the same? We have to be best in our way.
Well, let's talk to the man who's done such good work then, and talk to Grega, and maybe ask him to share a bit the secrets of this. I mean, we've already touched on this idea that there's a lot of work goes on behind the scenes in order to show people something simple from complex data. I mean, what do we need behind the scenes? What are the, for example, the AI, the big data techniques, the data discovery techniques that we really need to have behind the scenes here in order to present that simple information to the user?
I mean, first, I think that we just need to all agree that, yeah, nobody should do what we have done, because obviously it doesn't make sense. So I fully agree with that. But I think, I mean, honestly, there is some truth in that, is that I think that we should all focus to build services going further, because what we do is beautiful, or I don't know, whatever, but it's just shuffling pixels. The values is not in the pixels that we bring from one data to other data, but rather in what you extract out of it. And this is I mean, if you only focus on shuffling pixels, what we do is, yeah, you get only, I don't know, 1/4 of the way or even less, right? So I think it's so important that we focus to building things on top of other things, because then we can really build together something nice. And another comment on the previous question on the ARD. I mean, one thing that we need to really accept is that analysis ready data depends what kind of analysis you do, right? Not all the analyses have the same requirements. Talking about the radar data, you have CART4L, which is now the standard, but then people who say, yeah, sigma naught is just fine, you don't need radiometric terrain correction, and so on and so on. And I think there is a lot of truth in that, because sometimes you need this kind of data, sometimes you need that kind of data. And as soon as you start pre-processing the data, you make a decision that fits some part of the users, but many simply cannot make use of it. And now you can just make lots and lots of copies of data, but this becomes expensive from storage and processing. Now, going to your question, I think that, I mean, what is missing, or first of all, what is available? What we have available is cloud infrastructure. I think that is something that works. I mean, you have a couple, CreoDias being a very nice example. We were able to run large-scale drought impact processing on CreoDias, where we, I don't know, hit the object storage with tens of thousands of requests per second, and it worked just fine. I mean, yeah, there are always improvement possible, but it's fine. That's not a blocker. Then, assuming that the services that we do that process the data from one pixel into another set of data, that also is there. But what is missing are really the levels on top of it, which would extract information from this data into something that is actually useful for the wider set of users, because our target group are still just application developers, not end users. And application developers who understand remote sensing data, not about application developers who just want to get the information on, I don't know, when is the right time to harvest this specific field or whatever. So I think we should focus more on creating, we as a community, to be clear, I mean, Sinergise cannot do that because we obviously have very limited resources. We as a community should focus on building the next set of services that extract specific set of information from the data. This needs to be done in a way that they can be reused by many. Similarly, as we have done services that can be reused by many, the level on top can also be reused by many. And then other people will come and build applications on top of it without maybe even knowing that there are satellite data in the backend, right? This is the level that we really need to get to. And that, I think, I mean, to be honest, we are still quite immature in this process. Many of the data information extraction services are just somehow working. And again, here I'm referring to all of us here in this conference and beyond. We have prototypes, we have things that look to work, but in order to make this really, really work, there is a lot of effort needed. And we need to just focus on that to actually build something that can be reused further on.
We said we there a lot, we as the community. Stanisław, so the development of the DSs and the tools, they've owed quite a lot to the various funding that you've received from the EC, from the ESA. But one thing to say going forward is, what role do you see these agencies playing in supporting these infrastructure initiatives? And where should they really take a step back and let the markets, the community decide?
Well, first of all, out of this discussion we just had, I think we are at a very exciting moment where we see an industry being created, a European industry being created. There are many niches into which different companies may go and bring added value. This added value chain is long and brings a lot of value because everyone can find his layer and focus on that layer and play in that layer, optimize everything in that layer for the profit of the whole industry or ecosystem. I think this is something that is really exciting and successful. As for the market, the digital market in Europe is very fragmented. We are all small companies. When we compare to, especially when we compare to hyperscalers. And I think the way to compete with the hyperscalers is once in finding these niches we are talking about here. And the other thing is that hyperscalers usually have an internal, these are big commercial groups that usually have this internal advantage of having their main tenant, this anchor tenant, is within their group. We don't have, with our small size, we don't have that. And I think the role of the Commission of ESA is to act as this anchor tenant. As for the data part, yes, to provide and to support the availability of data, because this is what brings juices to the industry. Yes, this is what brings the juices to the industry, and this makes the whole ecosystem work and flourish.
Grega, maybe I'd like you to ask you to follow on from that and see if you think this is the appropriate setup for you as a company who I guess will be using the CreaDS a lot, and also whether you see that there's any changes needed in order to support your user base going forward.
I mean, just to confirm, yeah, CreaDS and similar diases, I think, is working just fine, as long as we assure that it has all the data available there and that it's available instantaneously, right? I mean, not all the clouds have that. And this is, I mean, to me, to us, this is a blocker. Because if you don't have the data, then we cannot do, and the data being instantaneously available. Now, in terms of the users, I mean, we have to be aware that, again, we are here in a small bubble with where we are people who work in this field for quite a few years or maybe even decades. But the people who are now coming into the field that we probably want to address, they will probably not start with cloud infrastructure. They will not start with a Eurodata Cube or similar platform because they don't even understand the data. I mean, I imagine that they might start in, I don't know, EO browser, something like that, where they can actually explore the data just visually, just to see, because again, the limitations of the users that they communicate are not, I don't know what kind of format the data is in, or whether it's gamma naught or sigma naught, but they say, why is this product so blurry? Or why, I mean, then we tell them, look, go and use the VHR data, and then they say, why there is no VHR data here for the last month or two, right? Because obviously you don't have the VHR data available systematically. So we need to accept the fact that people that are now coming into the field, they don't understand the limitations of the satellite imagery, nor the benefits and capabilities. I mean, they don't understand this multispectral, multi-temporal approach. That's something that we still need to learn them, teach them. And then when they do understand it, and when they realize what they can do, they will probably go off the platform or EO browser or something like that, and they will do it in their own environment, as it was explained previously, because people like to have the control of their own environment. And then they will use the services that are available from their environment. Now, this environment can be a virtual machine in the DIAS or can be in any of the hyperscalers. And as long as we have the APIs that can be used from many of these, then people are able to use it. So I know, like you have S3 to access the data on CreaDIAS, that's fine. Or you have Central Hub API and so on and so on. So I think that infrastructure part, I think it's okay. It needs to like really continue and needs to expand. we have the basic set of services, but what we need is like these modular components that actually solve the problems. I mean, here, I think European Union is nicely leading in the, at least in the agricultural field, with this area monitoring solutions. The Commission is basically enforcing the creation of these models, which, I don't know, detect mowing or crop type or land cover or whatever. These are the things that I think are needed so that people can start build on top of it. And then the other part that is needed, and it's really, really, really missing, is that there would be institutions who would be using all this data and services. I mean, the thing that frustrates me most is that we have all these services, like, I don't know, we have cloud infrastructure, we have Eurodata Cube, we have Sentinel Hub, but then you have the, I don't know, Joint Research Center using, building the system themselves or using Google Earth Engine. I mean, if we invest in all these services, all the institutions in Europe should also make use of these services themselves, rather than building yet another copy or going outside, right? So we need anchor tenants, which would actually generate the uptake, and then the rest will, and they will ensure that the services really work because they will be paying for the services, and then the rest will come and just follow.
Gedas, maybe a few last words from yourself before I try to fit in Slido questions about how you see this.
Yes, I already said that our focus is not on size of the exercise. Our focus is on accuracy. I mean, 95% of accuracy is a minimum standard to have to consider while offering a commercial service to a client, be it an institution, or be it is a commercial client or insurance company. So in our case, scaling the thing across the continent is possible or feasible or reasonable only as long as we have enough coverage of the data density. So Sentinel-1 in this case, as a radar, is covering mostly Europe, mostly European Union, 39, 40, 42 countries altogether. So Geomatrix has the infrastructure to easily cover all that region with all Sentinel-1 data, especially now when one Sentinel is missing. So talking about the reason of having a DS, I'm really sometimes frustrated because now when we have 10 terabyte size disks, which are pretty cheap already, and so on, it's really the moment when very simple people coming from almost the street, as Grega mentioned, very simple people with very limited understanding, coming to DS platform where all the data is visualizing itself, computing some indexes itself online on the fly. I'm really afraid that there can be some top level or some ceiling of the usability of such systems, because professionals would always go deeper and deeper in the analysis, down to the business intelligence gathering, down to big database construction, down to machine learning and other things which are far beyond remote sensing, which are far beyond any imaging as such. While the broad community coming to DS would probably limit itself just to the need to look at the data and make some subjective decision based on what they see. And I see here is the biggest threat to DS and to the whole concept and to the big projects which have been implemented, just to simplify everything down to the point when anyone can come and anyone can look and decide for himself that he knows everything and says, oh yes, now I know, I don't need any service, I don't need any commercial solution, I just have seen everything I have to see. So maybe it sounds pretty strange, but I'm a person who looks at things from outside, not from inside. And that's what I see. And that's what I have practically observed and felt myself, and have been punished by the economy, so to say, because of that, because of oversimplifying of the whole thing, of remote sensing, of Copernicus, of Dias, of what people have done in the background to make things so easy and so simple. I think it's a biggest danger. That simplicity really breaks the bone, could break the bone of the whole idea, after all.
Thank you. Thank you. We're almost out of time, but I would just like to follow up with one thing from the Slido. It's actually a group of linked questions, which is around the links between what we're discussing today on the Earth observation and other European initiatives, Gaia-X, Destination Earth, European data spaces. Stanislav, maybe you could just very quickly comment whether you see links here.
Well, EO-data is one of the typical big data applications. Yes, it's been here for a while. The biases have been here for a while. There are other
microphone, please.
Microphone.
There are other European initiatives that want to achieve this kind of EO data, of data-centric community in other areas. I think generally the idea of supporting an industry by delivering a data ecosystem that allows to share this data within the community. This is happening in the automotive, for instance, community in industry in Europe. This is something that empowers and makes an industry flourish, and it's a good way to support both the IT ecosystems operating in a community and the industry itself, making it more competitive, making it sustainable, viable.
Okay, thank you. I would love to continue the discussion, but unfortunately, I'm afraid we're out of time. We have another panel. So I would just like to say thank you to the panelists. Thank you to everyone who raised questions. And